Good morning. It's August 26th, and this is your daily brief in science. Here's everything you need to know. Recent research is shining a light on the potential of sirtuins, specifically SIRT1 and SIRT3, as therapeutic targets aimed at reducing oxidative stress and improving cardiovascular health. SIRT1 has demonstrated promise in various contexts, but its effectiveness in managing renal fibrosis remains a subject of debate, indicating a need for further investigation. A detailed review of SIRT1's biological roles reveals its involvement in critical processes such as lipid metabolism, oxidative stress, aging, inflammation, and autophagy, particularly in relation to renal fibrosis. In the realm of neuroinflammatory responses, microglia exhibit a dual role. They can both promote neuronal damage and provide protection, which is essential in understanding neurodegenerative disorders. Neurodegenerative disorders, characterized by the progressive loss of neurons, are becoming increasingly prevalent as the elderly population grows. Drug repositioning is emerging as a viable strategy for developing new treatments for these neuroinflammatory conditions, which currently affect around 50 million people worldwide. Recent studies have focused on the NLRP3 inflammasome, highlighting its role in neuroinflammation and programmed cell death, further emphasizing the significance of inflammation in these diseases. Oxidative stress is a critical factor in neurodegenerative diseases, contributing to synaptic loss and neuronal death. In parallel, vitamin D and its analogs are being investigated for their potential in treating kidney-related diseases due to their anti-inflammatory, antioxidant, and antifibrotic properties. Clinical trials have shown that vitamin D supplementation correlates with improved kidney health by modulating immunity and metabolism. These findings underscore the importance of personalized medicine approaches in managing cardiovascular health through targeted antioxidant therapies. Additionally, the special issue, Marine Anti-Inflammatory and Antioxidant Agents 3.0, highlights the potential of marine environments to yield bioactive compounds that could sustainably treat inflammatory diseases. The African swine fever, or ASF, is causing alarm among pig farmers in the Ebersberg district as it poses a severe threat to both wild and domestic pigs. Recent outbreaks in regions like Hesse and Rhineland-Palatinate have led the Ebersberg Veterinary Office to issue urgent warnings regarding the potential spread of this virus. The situation escalated with the discovery of a dead wild boar in Steinhöring, indicating that the virus is encroaching closer to Bavaria. The ASF virus has already made its way into several regions, including Hessen, Baden-Württemberg, and Rhineland-Pfalz, likely brought in through busy transport routes from Southeast Europe. In response to these developments, authorities in Saarland are closely monitoring the situation to prevent a local outbreak. The Ebersberg district, which is home to around 70 pig farmers managing over 3,500 pigs, has seen a decline in numbers due to fears surrounding ASF. Currently, there is no effective vaccine available to control ASF, as research continues to face challenges in understanding protective antigens and immune responses. Animal experiments have shown promise with the A137R deletion mutant for vaccine development, but further modifications are necessary to ensure safety. Managing ASF effectively will require a combination of reliable vaccine strategies, strict biosecurity measures, and rapid diagnostic capabilities. The veterinary office has advised residents to dispose of food waste only in closed trash bins to prevent wild boars from accessing it. Citizens are also urged to maintain distance from dead wild boars and report any sightings to authorities. The proactive response from the Ebersberg district has been praised, emphasizing the importance of collaboration among officials, hunters, and farmers to control the potential spread of ASF. A recent study from the University of Wisconsin-Madison reveals troubling insights about the COVID-19 pandemic's impact on life expectancy, particularly for Black men. This research indicates that these individuals have experienced significant increases in homicide rates, contributing to disparities in life expectancy when compared to their white counterparts. The study highlights homicide as a major factor in the reduced and variable life expectancy of Black men, drawing attention to the broader implications of social determinants of health. These determinants have been critical in exacerbating the negative outcomes of COVID-19 across various communities. Researchers have framed their findings through the lens of post-traumatic growth theory, suggesting that challenging life circumstances can sometimes lead to positive changes. This perspective emphasizes the potential for resilience in the face of adversity. The findings advocate for a comprehensive public health policy approach that addresses the complex interplay of social factors and health vulnerabilities. As society continues to confront the long-term impacts of the pandemic on marginalized communities, these insights underscore the need for targeted interventions and support. A recent study has shed light on an innovative approach to waste disposal by utilizing black soldier fly larvae, or BSFL, to process slaughterhouse blood mixed with kitchen waste. This research, conducted by a team from the University of Copenhagen, including Nana Roos, addresses significant environmental challenges associated with waste management. The findings indicate that larva meal can serve as a sustainable alternative to more harmful animal feed, which promotes a circular economy in livestock diets. In controlled experiments, BSFL fed a diet containing up to 20% slaughterhouse blood, demonstrated improved weight gain and enhanced nutrient composition, including higher levels of crude protein and essential amino acids. Despite the promising results, the cost of larva meal in Europe remains high, which calls for increased production and potential regulatory changes regarding its use in animal feed. As the demand for sustainable protein sources rises due to population growth and climate change, BSFL presents an attractive option for poultry production. This research adds to a growing body of evidence supporting the use of insect larvae as sustainable feed alternatives, particularly in the poultry industry. Nutritional analysis revealed that the crude protein content in BSFL increased with higher proportions of slaughter blood, while crude fat content decreased, further enhancing its viability as a feed source. Additionally, BSFL are recognized for their lower environmental footprint compared to traditional protein sources, primarily due to their high feed conversion efficiency. They are considered essential components of the circular economy, aiding in waste reduction and resource recovery in agricultural systems. Currently, BSFL is not approved for human consumption in the EU due to its strong flavor, although efforts are underway to change this. In Denmark, a large facility is mass breeding BSFL, which can consume a wide range of organic waste, further supporting sustainable waste management. A remarkable conservation effort has led to the revival of the northern-bald-ibis in Central Europe. The Waldrapp team, based in Austria, has successfully increased the population from 0 to nearly 300 since the project's inception in 2002. This initiative has been crucial in bringing the species back from the brink of extinction, as the northern bald ibis was hunted to near extinction by the 17th century. Through dedicated breeding and rewilding efforts, the species has moved from being classified as critically endangered to endangered. This year marks the 17th journey of the Waldrapp team, which employs human-led migration guides to assist the birds in traveling to Spain. Due to climate change, the migration route has been adjusted, now covering approximately 2,800 kilometers, which is 300 kilometers longer than last year's path. The journey is expected to take up to 50 days, concluding in early October, with the goal of creating a self-sustaining population of over 350 birds by 2028. To facilitate this migration, chicks are removed from breeding colonies shortly after hatching and raised by foster parents, which helps them bond with humans. Foster parents, including Barbara Steininger, guide the birds using a microlight aircraft, resembling a flying go-kart. Biologist Johannes Fritz emphasizes the importance of teaching the ibises their migration route, as they lack the instinctual knowledge typically passed down from wild-born elders. Climate change has posed challenges for these birds, leading to later migration seasons and forcing them to navigate the Alps in colder weather without thermal assistance. Once prevalent across North Africa, the Arabian Peninsula, and much of Europe, the northern bald ibis has faced significant declines in population, making these conservation efforts vital for its survival. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.